Good morning, everyone. The hydraulic system of all heavy machinery is tank maintenance that fails to achieve notable improvements or solutions. This results in low equipment productivity, which is why the DEFLOBO was created, an aquatic drone that aims to provide effective solutions. This will be designed and programmed in Arduino. This project will consist of investigating the inspection of hydraulic systems in machinery such as an excavator. The specific system for inspection and solution will be hydraulic tanks. For this, an aquatic drone was made, which will be located inside the tank in order to inspect and solve any faults that may occur in such. The corresponding programming and design will be carried out in Arduino for this aquatic drone.
Problems facing the drone. This project was carried out to detect faults in the hydraulic tank of the 313 GC excavator. For this, the operation of the hydraulic tank must be understood. Hydraulic tanks have the function of having oil, although it is not the only one. The tank must also remove heat and separated air from oil. Tanks must have adequate strength and capacity, and must not allow external dirt to enter. The non-pressurized tank has a ventilator that differentiates it from the pressurized tank. Ventilated allows air to enter and exit freely. The atmospheric pressures acting on the oil surface forces the oil to flow from the tank to the system. The vent has a screen that prevents dirt from entering the tank, and that is why this project is carried out to help detect failures without any danger and help resolve them.
The project planning presents three parts in this operation: mobility, actuators, and sensors. With the help of the Tinkercad, we can design the process of the inspections of fault in the hydraulic tank of the 313F LGC excavator. Firstly, the drone will have a 360-degree movement, which will be powered by two direct current motors controlled by an edge brake. This movement will be changed through the two LEDs on its sides to see if it's turned to the left or right. The drone will also be able to ascend and descend through two micro servo motors, one to halo access for the oil to submerge, and the other to open the compressed air valve so that it expels the fluid and rises to the surface. Secondly, our drone will present different sensors in its operation. The ultrasonic distance sensor in order to record anomalies in the tank, whether it be dirt particles or contamination that could affect the performance of the tank. The temperature sensor indicates the temperature of the fluid with which it works to know the viscosity. The IR sensor will help us in the inspections since the visions of the maintenance operator is limited by light. This IR sensor allows us to observe space and objects without a need for light. The piezoelectric will also be included in order to measure the pressure, acceleration, tensions, or force resistance in the hydraulic tank. The purpose of the gas sensor when our device is at the surface is to record the density of the gas contained in the tank and in the oil change. The whole works as an alert for density, gas proximity, and temperature parameters. The micro servo motor at the top is the extract sample. It opens a gate end due to the pressure of the environment. It absorbs fluid and has it totally insulated. The light bulb simulates a video camera in order to record and guide the movements carried out by the device. The two microservo motors are cleaning tools for a targeted area through the vibrations. The engagement of the tank walls is achieved. All of this is controlled by a remote control with simple guidance signals, directions, and submergence. Finally, an auxiliary system was placed at the base of the hydraulic tank, formed by a distance and temperature sensor, to locate the contaminating particles and know their exact location by means of forlets of different colors. This light up depending of the distance to which are of the sensor.
To answer this question, the code will be analyzed from the Tinkercad platform. First, we will talk about the code regarding an steering system, which has the work of controlling the entry system that will make it possible to navigate the DEFLOBO drone. Will be include the libraries from remote control and microservo motors, then assign a pin to each actuator we use, such as the DC motor power and direction sources being the outputs. In addition to adding the servo motors on pins 10 and 12 and assigning them a position of 0 degrees. To encode the remote control, we use the buttons as cases within a loop RC decode with the variable called result value, and assign a function for each action depending on what is pressed on the remote control, to end with a break, which will restart the loop waiting to press another button. All cases are due to a change in the power and direction system of the CC motors, so we will use the analog bright and digital bright commands to give a value and in RPM with the variable speed and provide power to the engine direction with high and low as segments. This occurs in cases for the forward, backward, turn left, turn right, and stop functions. Then the speed up and speed down functions are based on changing the variable speed, adding or removing speed in RPM with the commands analog bright on the PWM power, M1 for engine 1 and M2 for engine 2. Only functions while moving forward and backward, but not when performing the turn functions. The open float and open arc functions are responsible for assigning then a position angle between 100 and 0. The next is the sensor system, responsible for data collection with different components that will tell us precisely how the tank is inside in real time. The code begins with the declaration of libraries for remote control and microservo motors. Then, we have the declaration of microservo motors and pin assignment for the different sensors, motor, and LEDs. Here we will find the voice adapt function that stores the input speed in bits per second and the input and output options for the sensors, as well as the pin assignment for the servo motors. To encode the remote control, we ask the button as cases within a loop RC decode with the variable called result value and assign a function for each action depending on what is pressed on the remote control, to end with a break, which will restart the loop waiting to press another button. The open gas function adds a variable value that by means of an analog read will make a reading that we then match to a similar range from 0 to 100, and then analyze the data with a digital bright that compares the variable value with the numbers 30, 50, and 80, and thus be able to know the density of the gas and light the LEDs. Then we have the open-this function create the variable of duration and cm for a later calculation. Before is it assigned to the sensor as output and then assigned with digital bright the sensor ignition. Then using the function microsecond to centimeters, we convert the duration into centimeters and send to monitor in series a distance value in cm next to the LED lighting, depending on the distance of the particle with respect to the drone. OpenTemp start with variable mapping temp C and subsequent use in the next function, then being shown with serial print. OpenMus will start activating the servo motor at 50 degrees, and after a second it will return to 0 degrees. OpenLim drives the servo motors by positioning them at 100 degrees, and after 2 seconds will assign with digital bright the power to the vibration motor for 3 seconds and then return to the starting position everything.
Here are some conclusions. It can be concluded that the maintenance of the system is facilitated by the drone as the first prevention measure. It has an easy handling which will allow the operator to go to a focal point where faults detected by the sensor are found. Prediction and improvement in the 45% reduction in corrective maintenance. The programming of the electrical circuits that compose it must be truthful and precise for a correct operation. That is why with the help of the Tinkercad simulator we will see this in practice. This project is possible with the help of the Introduction to Programming course. Thanks for watching. Goodbye.